I'm Wenli. Last time we studied the structure of ANOVA table in regression analysis, and I explained determination coefficient shortly. Today, I'm going to explain determination coefficient since it is very important concept in regression analysis. Let's see a little more about determination coefficient. Let's take a closer look at the explained variation. Variation terminology is similar sum of squares. Okay, in ANOVA we said sum of squares, but here in regression analysis we also use same terminology, sum of squares. But another thing you need to understand is explained variation and unexplained variation. The terminology just changed, described earlier last time. The following graph, this graph, illustrates that at each xi, the deviation is what? Sample values, okay, minus their mean, y bar. It is always a deviation. Deviation is the sum of residual yi minus yi hat and the difference yi hat minus y bar, right? Let's see here. At xi, what is this? Yi minus y bar. Y bar means the mean of y values. Y bar, this one is yi minus yi hat. This one is what? Residual. And yi hat minus y bar, here, this part, sum of those two parts, right? Okay, and we obtained relationship of the sum of squares is this part squared summation of a squared thing equal to this part summation of residual squared residual plus sum of this part squared this part. Okay, the difference. So let's see yi hat minus y bar, this part, okay, this difference corresponds to the slope of the line. What is the slope in this line? Slope means bottom. What? This part divided by bottom line here. That is slope, right? Indicating the magnitude of effect that x has on y. Slope means magnitude of effect that x has on y. In other words, the slope represents how y is explained by x. What? The slope represents how y is explained by x. So the sum of squares of this part, say summation yi hat minus y bar, this part, summation squared, is referred to as explained variation. Understand that? Explained by what? Slope. By line. Slope is important in line, this line. Intercept is not important. The residual, which are the observed values of errors, represent the unexplained part. So the sum of squares of residuals is referred to as the unexplained variation. Unexplained variation. That's why two terminology, explained variation and unexplained variation, can be explained, can be understood. The coefficient of determination is an indicator of how much the explanatory variable x accounts for the variation in y. So r squared is defined like explained variation divided by total variation. So SSR, regression sum of square, its name, divided by total sum of squares. So SST equal SSR plus SSE, so that this R square lies between 0 and 1, right? Note R, square root of r square, r with a sign plus or minus denotes the correlation coefficient. Typically, the correlation coefficient is represented by lowercase letter, small r, instead of a capital R. Okay? Example. It is simple, but very what? Neat explanation of R square, I think. In the regression analysis of sales and the number of employees, we have seen this example. The coefficient of determination is 0.817. What is this? From ANOVA table, what is the total sum of square? Total sum of square, sum 4.9 plus 1.1 is 6 bottom. And regression sum of square is 4.9. 4.9 over 6 is 0.817 r squared. Okay? This means that number of employees explains 81.7% of the sales amount. The correlation coefficient is approximately 0.9. Square root 0.817 is near 0.9. 0.9 is very high correlation coefficient. So 81.7 of sales amount is explained by number of employees. What else? In other words, 18.3% of variation in Y will be explained by other variables, other other explanatory variable. Okay, it can be the area size, something like that. You get it? Okay, that's it today. Thank you.